Microservices architecture, turning one bug into a distributed team building exercise. Take your big, comfortable monolith and slice it into tiny, independent services that all pretend they don't know each other. Each service focuses on a single job and manages its own database, making it independent from the rest. They're loosely coupled, highly deployable, and emotionally unavailable. On paper, it's beautiful. In production, it's Kubernetes, caffeine, and coping mechanisms. Every outage turns into a group therapy session where everyone swears it worked locally. But hey, it's how Netflix scales, how Amazon survives, and how startups justify Kubernetes. Master-slave architecture, one brain, several obedient clones, and zero democracy. The master handles the main tasks, writing data, managing state, and giving orders. The slaves, they just replicate, read, and stay quiet. It's great for scaling reads and keeping backups, until the master crashes and everyone forgets what to do. Then it's pure chaos and finger pointing in distributed form. Reliable, proven, and slightly outdated, like the boss who refuses to retire. Peer-to-peer architecture, where everyone's a client, everyone's a server, and no one's in charge. No central authority, no master node, just a bunch of equal peers trading files and trust issues. It's the reason torrents, blockchains, and shady college file sharing networks still exist. It's decentralized, resilient, and gloriously uncontrollable. When it fails, it's everyone's problem. Event-driven architecture, the system where nothing happens until something happens. Instead of constant requests and responses, everything just reacts to events. The producer creates events, the message broker distributes them, and the consumer listens and reacts to those events. It's async, scalable, no central control, no waiting in line, just pure, glorious chaos that somehow works. The good news? It handles millions of events without breaking a sweat. It's perfect for stock trading, IoT systems, flexible, fast, and terrifying to maintain. Broker architecture, the system that exists purely to tell everyone else what to do. You've got components that can't directly talk to each other, so the broker steps in to route messages, manage requests, and take all the credit. It's the office manager of distributed systems in doing everyone's work and pretending it's strategy. It's reliable, scalable, and perfect for messaging-heavy apps until the broker becomes your new bottleneck. When it's up, everything flows. When it's down, everyone just stares at each other. Space-based architecture, for when one server just can't keep up with your ambitions. You split data and processing across multiple nodes, all working in memory, all pretending to be one big happy system. When it works, it's lightning fast. When it doesn't, it's like losing a puzzle piece in another galaxy. No central database, no bottlenecks, just instant responses fueled by panic and RAM. Perfect for systems that promise 99.999% uptime and deliver emotional damage instead. Microkernel architecture, the core idea that your system should do less and still somehow do everything. You start with a small, stable core, the microkernel, handling the boring essentials like communication and security. Then you bolt on plugins for the fun stuff, like giving your app personality through sheer chaos. Core stays lean, plugins do the heavy lifting, and you pretend it's all perfectly coordinated. The beauty? You can add new features without breaking the old ones. The horror? When 10 plugins fight for control and crash the entire system out of spite. It's modular, flexible, and great for products that evolve like Eclipse, VS Code, or that one legacy platform nobody wants to touch until it breaks everything. Layered architecture. Everything's divided into layers of subtasks, each sitting politely on top of the other like a polite Jenga tower. Each layer does its own thing and pretends not to notice when the others are on fire. You've got presentation, the pretty face that takes user input. Business, the one that actually does the math and logics. Application, the translator nobody appreciates. And data, the grumpy old database that remembers everything. Each layer is independent, so you can change one without wrecking the rest. It's scalable, flexible, maintainable, basically the architectural equivalent of don't touch my code. But every advantage comes with bureaucracy. Data has to travel up and down the chain like an intern waiting for approvals. More layers mean more latency. More latency means more coffee. Still, it powers CRMs, banking apps, e-commerce, basically anything that screams enterprise. It's neat, structured, and kind of boring, but it gets the job done. Client-server architecture. The idea is simple. One side asks, the other serves. The client asks for data, the server delivers, and somehow that counts as balance. The server stores, processes, and manages all the logic and data. It's fast, centralized, and it scales easily. Just keep adding servers until accounting tells you to stop. But when too many clients show up at once, the server panics, drops requests, and goes down faster than your Wi-Fi at 5 p.m. Still, this model powers everything from web apps to email, multiplayer games, and your favorite cat meme website. Simple, predictable, and perfectly balanced until your backend developer goes on vacation. Pipe filter architecture. Data goes in one end, magic comes out the other. Each filter does a tiny job, transform this, clean that, validate the mess before passing it down the pipe. It's like a sushi conveyor belt, but instead of food, it's half broken JSON. Super modular, easy to test, and great for compilers or data pipelines. But if one filter sneezes, everything behind it catches a cold. Elegant, simple, and totally allergic to bad input. That's it. See you in next video.